Even if you have 6, you should be done.
Excuse me.
Okay, so what do we got?
Who are we
Determines the
starting
charge
from?
rate of the alternator.
Please.
Field current? Well, are we just starting from one end going to the back, or we just blurting it out?
It's just what we can do that.
Well, since there's 6 of us, we can start anywhere.
Um,
Let's start with Terrence. You take question number 1.
I put a B.
B?
Yeah.
Okay. B is not the right answer.
is it A? No.
It might not be something you would guess.
What was that?
The
Rate of
charging
charge, or charging rate.
Oh yeah,
How
because it
much
has
does
to
it
stop
need,
when it gets
depending
to
on the
12.
condition of the
Okay.
battery? Does the battery need more or less?
That makes sense.
Yeah, okay,
Is C the right answer?
Yeah.
yeah.
What is the purpose of the voltage regulator in the charging system? To control the output of the alternator? A?
Okay. That is the right answer.
What is the advantage of computer control in the charging system?
B?
B-boy?
So advantage of computer control in the charging system.
Is it B?
Creates heat for the alternator? Definitely doesn't do that. Determines the charge rate of the alternator? It should be that. Provides temperature compensation. I don't know about that. Improves engine idle.
Why?
I don't know about that.
What is the answer?
Well, the reason I'm questioning it is because it's saying B and I don't like that answer.
When it only idle? When it's like sitting?
Improves engine idle.
Yeah, I was stuck between B and C. I mean B and D.
I mean, D doesn't make sense to me at all because if it's improving the engine idle, every car's engine idle is improved if they're newer.
Yeah.
And that wouldn't even be improved, that would just be
Well,
factory.
one of the things that it can do is it can bring the engine idle up
Yeah.
if it needs to turn the
Charge,
alternator
yeah.
a little bit faster, get a little bit charge out of it.
Mm-hmm.
I don't know that I really like that answer, but that's what they're,
So what would
It's
you
not gonna-
say the right answer is? B?
probably.
Okay, as long as I got it somewhat right, at least from your point of view, I'm good.
So because the logical thing would be B, but the book wants D, if we get a question like that, how should we answer it?
You won't,
Oh, we
you won't, yeah, you won't see that, so,
Okay.
yeah, don't even worry about it. If you were gonna see it, I would let you know exactly what, how to answer it.
Okay.
All right, how do you prevent a discharged battery from reaching the maximum charging voltage? Or what can do that?
Is it charge?
Think about charging voltage. What can determine charging voltage?
The battery.
D.
A.
I'm sorry, I messed you up.
It's D.
Yeah, battery's level of discharge, sorry.
Dinosaur.
Yeah, I messed you up on that, sorry. All right. Purpose of field current.
Was it because of the field current in the charging system? Control the output of the alternator?
It's 8.
Mhm.
What is it?
And the last one, EPM, that's just system used on GM vehicles for electric power management. All right. Last chapter in the book, chapter 55. Let's go through this real quick. This is a lot of what we've seen already, but there is a few new things in here. And there's also the last part of the test as well. Okay. Here we go, methods of testing the charging system, how to inspect and adjust drive belt. Most belts don't have adjustments on them unless you have an older vehicle, like somebody in the back. Discuss alternator output, minimum requirements. How to remove this symbol, we're not gonna get into that really because we don't do that anymore. Remanufacturing alternators, that's not the techntechnician's job anymore, although it used to be, that's why it's in here.
Wait a minute, say that again, I'm sorry. What did you say used to be a technician's job?
Rebuilding the alternator, taking it apart. If an alternator failed, you would take it off the car, take it apart, test all the components in it, find out what went bad, replace the bad parts.
And how long?
Put it back together, put it back on the car. You didn't just put a new one on it.
How long would that take?
Not really a lot of extra time, maybe an extra half an hour. Yeah,
To
it
take
wasn't,
it apart and all that?
yeah, it wasn't bad really. They're pretty easy. I could rebuild a complete alternator if it was off the car in probably 15 minutes.
Are you serious?
Yeah.
Because you've done it so much.
Yep. Yep. Nothing to it really.
Are they still the same back then?
They're a little bit different. I mean, they'll have all the same components in it, but they're a little bit different now. But as far as the basic parts of them, yeah, they're all the
Are
same.
you talking about the alternator for your car or for every car?
Like an older car like mine. The newer ones, they're a little more work because they don't really design them to be taken apart and rebuilt by a technician. So they're a little bit more complicated to get apart and stuff like that. So, but the other ones, older ones, were pretty easy. All right, battery must be at least 75% charged before testing the alternator and the charging system. The voltage, set your voltmeter DC volts, connect the leads to the battery, run the engine about 2,000 RPM. You should be somewhere between 13.5 and 15. I think that's going to be a test question as well. What is normal charging system voltage? This is what you're going to say. Okay?
13, 15.
13.5 to 15. Many computer-controlled charging systems can be diagnosed using scan tool. Charging voltage can be monitored. Field circuit can be controlled with the scan tool as well. You hooked your voltmeter up to your car and started it up. You should see something like this. That would be normal. Again, 13.5 to 15 is fine. And we can do that. As soon as we're done with this chapter, we'll go outside and do a little testing on the car. Okay. Yes, you can use scan tool to diagnose some of the parts on the alternator. Let's see. Use test light to check defect fuse link. This is a good idea. If you have an alternator that is not working, it's a good idea to make sure before you change it, you have power right here. This is the big wire on the back of the alternator, the output wire. Take a test light, round one end of it.
That's what he told me not to touch. That little part right there, because I had the flat head. And he said, be careful, don't touch that.
Yeah, if you touch it with a screwdriver, yeah.
Yeah, that's what it was.
Mhm,
That's
sure.
what it was.
Yeah. Because this is battery power.
Yeah.
And if you took let's say you touch this with a screwdriver or something, and then you touch the case, then you're in trouble.
Yeah.
And you're gonna get a big, nice spark.
Yeah.
It's gonna scare the crap out of you. Won't hurt you, but it's gonna scare you.
So what
Make
do you-
sure you have power here before you change an alternator, because you may have a problem with that connection there. And if there's no power here, that's why the alternator doesn't work.
Would it be mean if I made my kids do that?
That's crazy.
It would be extremely mean.
You wanna learn about cars? Touch this.
Yeah. Yeah. All right. Belt is pretty self-explanatory. Make sure the belt looks good. Make sure it's tight. That's really all they're getting at here. You can use different ways to check belt tension, but normally you can just kind of pull on the belt by hand and tell if it's tight or if the tensioner is good, or, you know, there is tools to do it, but honestly, I've never used one of those tools ever.
Is it possible to over tighten it?
Not if it has a tensioner on it. But now, if you have adjustable belts like yours, it is possible to over tighten it, yes.
Now, if I over tighten it by accident, will it squeak?
No, it'll wear the bearings out prematurely. So, we'll check it out once we get out there.
Okay.
It's here, right?
Yeah,
Yeah. Yeah, we'll check it out. We'll see how you did on the belts.
yeah, I think Charles and I did pretty good. You did pretty good.
It's still running, so yeah, you probably did okay, right? So we'll check that out when we go out there.
Car make it here, so I think
Yeah, pretty much.
Again, just check the condition of the belt. They do make belt wear gauges. We've seen this before in another chapter. All that does is just basically checks the depth of those grooves, see how far the belt's worn out, because it wears down as it runs, right? And as far as belt replacement, pretty easy, but I always recommend making sure you know how it goes back on before you take it off, because sometimes it can be confusing. Okay, which way did it go? You would put it back on, and you're like, I don't know which way it went. I don't know how it came off. Best to make sure you know what the belt routing is before you take it off.
Question. So, I've asked him a while ago, but I completely forgot what he said. Some cars, I don't know if it's all cars, but his car specifically, when we took the motor out, first of all, we took the bumper off, and then the front part of the frame, we were able to take that off, so we could just kind of put it right on the crane and roll it right out. Is
Okay.
that possible, or is that something like he probably had to do to cut the frame up or something? Because I've seen other cars like that, like watching videos, like, but specifically it's usually I've seen it on drift cars or like a track car. The front of the frame,
Uh-huh.
you're able to pull that out like it's like you know how like if you were to slide it into another part of the frame, you
Uh-huh.
can slide it out of the frame, put it off to the side, hook the crane up, and then just slide it out, so you don't have to like lift it over, be careful with it and everything, just so you have more space to pull it out.
That's interesting. I've never seen that.
Because that's how he did that. He took a picture of the belt from the front. Most of the time you're looking down in here trying to figure it out, or you
Yeah.
gotta look up a schematic. He just stood back, took a picture of it, so he knew exactly how to do it. Yeah. I don't know if that's something that they do to cut off the frame so it's easier to do, or,
I don't think I've ever seen that, but
because he could just take it off, put it back on, bolt it in, take it off, put it back on, bolt it in.
Hmm.
Like it's still intact and it's still strong.
oh yeah, yeah.
I just don't know how that
I
works.
don't know how that works either.
Okay.
Belt tension, some of them do have marks on them for proper location. They'll let you know if the belt's stretched. That's all that is. We've seen the overrunning pulley before. Nothing new there. Raise the belt, check belt tension. AC ripple voltage check. We'll do that when we go outside. Good alternator should produce very little AC voltage or current output because it's controlled by the diodes, rectifier, bridge, right? Not supposed to really get much AC out of the alternator, but if you put your meter on AC voltage and hook it up to the battery, you'll see an actual voltage reading, but it shouldn't be too much. What should it be? Less than?
Is it 0.78?
It is less than 400 millivolts.
No, okay.
0.04.
Oh, 0.5.
It's kind of like your voltage drop.
Yeah, it's right there.
On your voltage drop test,
Right in front of his
you
chest.
really shouldn't have more than that. 2 is good. Remember how it said it shouldn't be more than 200?
Yeah.
Yeah, maybe on the ground side, but you might see a little bit more on the power side if you're checking that. But it shouldn't be any more. It shouldn't be any more than this at any connection for a voltage drop. Okay.
Okay.
Same with the ripple,
Okay.
which we'll look at when we go out.
Oh,
Check it out here in a little bit.
I see it here on page 636.
Now it tells you in order to check AC ripple, it tells you to put one meter lead on ground, put your meter on AC volts, put the other one at the output wire on the alternator. Sometimes you can't get to that. You can put it on positive on the battery. because a lot of times this terminal gets its power directly from positive cable. So a lot of times that's not convenient to get to that terminal.
So which one are you saying, the red wire or the black wire? The positive, you said?
Yeah, black on the ground,
So
case, something like that.
You said it's okay to connect it to the battery?
Yeah, if you're gonna do an AC ripple test, because a lot of times you can't get to that output wire on the alternator. Yeah, battery voltage can be read through your power, power outlet things, you know, where you plug in like that for phone charging or whatever. How many cable major AC amps to check alternator? Yeah, you could do that too, I'm thinking. I'm trying to think if I have, my meter will do that. Start the engine, turn on the lights. Most cars, the lights come on when you start the engine, at least the daytime running lights anyway. Place the clamp around either cable, should be within 10% of the specified alternator rating.
So exactly, what is a ripple? Because I see how to check for one. The principles.
What that is it's how much AC voltage is actually coming out of the alternator.
Okay.
It's gonna be a little bit, because it's not perfectly
Okay.
converted to DC, but for the most part it is.
I see it here.
So if you have a bad diode, a rectifier bridge or something like that, that ripple is gonna be really high. And a lot of times the alternator will make a whining noise too. The other thing is, if you suspect an alternator is bad, sometimes, believe it or not, you can smell it. You can just do the sniff test on it.
Smell it.
Just give it if it smells burned, it's bad. Okay, if it has that electrical burn smell, you'll know right away. Okay? Then it's bad for sure. This is just the same thing again, but again, if you can't get to that terminal, you can use the positive cable. Make sure that all alternators properly converting AC to DC is all that ripple checks is for. On the voltage drop, we've done that before in other ones, we know how to do that, right? Start the engine, run at 2,000 RPM, turn the headlights on to create an electrical load, set the meter to DC volts, positive the output terminal of the alternator, black to the positive post of the battery. Less than 300 millivolts satisfactory. Couple of different ones. You're checking the power on one, the ground on the other. Power on the left diagram, ground on the other side. So either way, you're checking the ground side for voltage drop, you're checking the power side for voltage drop. See where the readings are different. On the power side, it says 400 millivolts is okay. Ground side says shouldn't be more than 200 on the ground side. But if you use the 400 millivolt rule, as far as shouldn't be more than that on either side, you're all right. Voltage drop power side, again, one lead on the output terminal, the other one on the positive post to the battery. Start the engine, turn the lights on, create electrical load. Speed the engine up about 2,000 RPM. Same thing ground side. Alternator case. Ground post on the battery. Carbon pile load testers, they don't have anymore. That's too bad. They used to work really good.
What is it?
It's a machine that would actually check charging starting system and actually load test a battery.
Oh, I forgot to tell you, I'm sorry, real quick, this is not on subject, but I finally saw rotors being,
Did you?
yes, I did.
Surfaced.
I saw two different machines. I saw the one that they actually take to the car and it does it while
Oh, the
it's
on-car one,
car.
yep.
Yes, I
yep,
saw that one.
Yep,
And then I saw the other one, cause at Toyota, like I'll walk through the shop and
Yeah.
just to walk around, you
Yeah.
know? And then the other one I saw where it was actually the machine and he had to take it off.
Right.
It said it was
Uh-huh.
the same principle,
yeah, it does the same thing, yeah.
but it's, you know, just a different machine, but to
Mhm.
actually see it in action
Yeah.
and see it being,
Yep,
what's the term, what's the word?
Surface?
resurface, or
Resurface,
they call it,
yeah.
sometimes they call them turning it.
Yeah, resurface, it was like really, and it collects it, all those little shavings, it
Mhm.
collects it
Yep,
and
yep.
very minimal mess.
Makes great lawn fertilizer.
I mean, it was great, like, it was really cool to actually see that, I
Yeah.
have to tell you.
The on-car brake lathe is pretty cool too, because you don't have to take it apart, you just gotta take the brake caliper off and,
Mhm.
you know, put the thing on there, it spins it, and it cuts it right on the car. It's
Mhm.
actually, honestly, you probably get a better job with the on-car one.
Really.
Yeah, because it turns it with it connected to the car, which means you get a perfect surface on the rotor with it actually on the car. You know, so it's actually probably the better way to do it. And on some where the rotors are hard to get off, that on-car lathe is great. Yeah.
Another off-topic thing, but really quick. Alex is already getting a promotion in main shop.
Oh,
Big
is he?
Burly, big beard.
Yeah, 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 I know what you're talking about, yeah,
Yeah.
he was in the last class.
Yeah, he's already got to get a.
Very
promotion
cool.
to Main shop.
All right, that didn't take long.
No. He's doing a good ass job.
Good, glad to hear it. Okay, minimum required alternator output. Let's see, electrical alternator is able to keep the battery fully charged. Let me see what you have here. Maybe able to check that too. I'm just trying to figure out what tests we can actually do. Purpose of the output test is to determine the maximum output capability of the alternator. This is removal and disassembly, which we don't have to worry about. There's your diode. That checks the same way we did that one. This one just got 3 legs. So you do it the same way. So you would just check one of those and then swap the leads and check the next one, swap them again. And you should get the same readings we got with that other diode. The diode should be OL one way, 700 millivolts the other way, which we saw when we tested that other one. Rectifier bridge, again, just a series of diodes for converting AC to DC. Slip rings on the rotor. Alternator overhaul. No alternator overhaul anymore. Remove it, put a new one on it. Let's see if I messed this up. These all look okay. Last one.
There you go.
Last chapter. You already got one, of course you
Thank you.
do. You do a lot of paper in this class, don't you?
That is.
So at this point, at the beginning, if you'd known that, you should have said, I should have got myself a notebook or something. and a 3-hole punch. I could have kept all these in order, right?
I have my binder, I just don't wanna stuff everything in there, so when I need it, I can pull it out. My binder's in my backpack when I'm ready to put everything away. I'll throw it in there. at you if you wanted to test your car?
Huh?
He said, I said he gonna be mad at you if you wanted to test your car.
Oh.
Okay.
Yeah.
I'm gonna take it
Have a good one, guys.
back. You too, drive safe.
Got a little message on the board.
You have a what?
You have a message on the board. You.
There's a message for you on the board, on that physical board.
Turn around.
There is.
She had to go to the doctor appointment.
Oh, that's right, she told me that yesterday, didn't she? What do you mean there's a message for me on the board? What the hell are you talking about? All right, then there was 5. Remember, we started off with 9, remember that?
Yeah.
Yeah, we had one guy drop out after 2 days. Remember he was sitting where you are?
Yeah.
Abdu, I think his name was, yeah. And then Carlos said, I've had enough after a couple of weeks, and we lost 2 pretty quick.
Do you ever chase you?
Yeah,
No.
his book and stuff is still sitting over there. He left all that stuff. That's his notebook, and, I was sitting on there underneath the, soap, hand sanitizer. I don't know, man. Some people don't want a free education, I guess. That's kinda hard to believe.
What happened?
Huh?
What happened?
What do you mean?
People don't like free education.
Yeah, that's what I mean. It's hard to believe that somebody, the people pay a lot of money to go through a class like this. And I mean a lot of money. They spend years paying it back. And they still gotta go look for a job, and they gotta buy their own tools. You guys got it made in here. Don't mess it up. Because they won't let you do it again. I think for like 2 years or something like that. I found this on my desk. I meant to give this to everybody on the first day of class. This is something everybody should benefit from. There's 10 things that require 0 talent. That means anybody can do it. Something to think about. Okay?
I don't have number 5 for today.
What's it say?
Energy.
Huh?
Energy.
Oh. Well, you know, sometimes that comes and goes depending on other factors, but. All right. I'm assuming we're all done with this, right? Am I wrong? Or am I right?
You're right.
Let's do it then.
I'll do one and two.
I'm sorry.
I'll do one and two.
Oh, all right.
Okay. For number one, power new slip rings attached to the rotor during alternator rebuilding. B.
They are soldered on, yeah. And you're not gonna do that, but that is the right answer.
Number two, which of the following would not be used to check for drive bill wear? A.
That is correct. All right.
Number 3, technician A says that a voltage drop test of the charging circuit should only be performed when current is flowing through the circuit. Technician B says to connect the leads of a voltmeter to the positive and negative terminals of the battery to measure the voltage drop of the charging system. Who is right?
Neither.
B?
Hey, there you go. A is the right answer. They want current flowing through the circuit, otherwise how would you be able to check for a voltage drop if there was no current flowing through the system? If you put the positive and negative leads on the battery, all that's doing is measuring the battery voltage, it's not measuring voltage drop. Right? So A is right, good.
For technician A says that charging system testing requires that the battery be at least 75% charged. Technician B says that a digital multimeter cannot be used to test charging system voltage. Who is right? Technician A?
That is correct. Of course you can use a digital multimeter to check charging system voltage. We'll go do that in a little bit. And we can't look at her car because she took it.
That's what I told her.
Maybe we'll just do it tomorrow. We'll have plenty of time tomorrow because we're done actually. So we'll just do it tomorrow. All right, we're testing alternator minimum required output. What is the acceptable reading?
Less than 30.
Minimum output required, what's acceptable reading? Oh, did anybody actually find the answer to this?
To 6.
What is it?
5.
To 6.
Yeah,
5.
no, number 5.
Is it D?
Mm-mm.
2 or 5?
You're thinking of the current through the
A.
brushes.
Flashes,
Yeah, not A.
Is it B then?
It is. 5 amps greater than the accessory load. So what that means is, if you're driving around with everything on, that alternator should be able to keep up the accessory load. It actually needs to be a little bit over that, otherwise the battery would go dead while you were driving, right? So let's say you were driving with everything on. Let's say it was raining, the wipers were on, the headlights were on, the radio was playing, everything was on. Every electrical load you could think of. Let's say you had the seat heater on, if you had a seat heater. All that stuff, right? If the accessory load exceeds what the alternator can do, the battery would go dead while you were driving, right? So 5 amps above the accessory load will keep the car running.
So if a car dies while you're driving, the only thing that's gonna happen is everything's gonna shut off.
If what now?
Like everything's gonna shut off. Everything.
Battery too.
If the alternator quits working?
Well, the battery shuts off. Like you're driving, the alternator's not working, and the battery's not working.
Okay, so here's the deal. You're driving down the road, and all of a sudden, your alternator decides, I've had enough,
Yep.
and it's not charging anymore. So now your system voltage goes from whatever it was, 13.5 to 15, to battery voltage, about 12.5, okay? Now you're driving on the battery. So that battery is going to go dead probably within 30 minutes, depending on what you have on. And then once that happens, the engine is shut off.
And they're all,
What's the car gonna do?
you're going slow, you're putting your foot on the
The
pedal.
engine's just gonna shut off just like you shut the key off.
Yep.
You're not gonna have.
And you're gonna be on the side of the road. You're gonna be stuck,
Yeah.
okay? Normally, if your alternator goes bad, the battery light will come on the dash. The little red thing that looks like a
That's the only
battery.
reason the battery light was on, if your alternator's not working.
Yeah, there's no like alternator light, it's the battery, okay? So if that red battery light comes on, means your alternator's not charging. Means you're not gonna be going very far, so you better get where you're going and, right? Because now you're driving on the battery, okay?
That's not, so the only reason the battery light comes on is if your alternator's not working.
Right,
Alright.
yep. Okay, let's see, where were we at? Six?
Six.
Yeah, six, right?
The 6 I got blue.
Yeah, I think that is correct. Yep, it is. Identify this component. The rectifier bridge, yes, it's just a series of diodes that converts AC to DC. That is the right answer.
I'm reading. Alright.
I'm sorry?
I'm reading.
Oh,
I'm going with B.
B is a good idea. Don't ever disconnect the battery with the engine running. Never do that.
But what happened?
Damage the electrical system. Because your battery is your voltage stabilizer. If you take a battery cable off the engine running, it's not gonna be happy. You might end up losing some computers.
Number 9.
Number 9.
When performing an alternator output test, which of these tools would the technician choose?
Guess what?
What's gonna go?
It says,
Got a flashing 9 on here. And the answer is what?
a load tester.
That is the right answer. A load tester.
Technician A says that by full fielding the alternator, you are bypassing the voltage regulator. Technician B says that full fielding can possibly damage electronic circuits, so it is no longer a recommended test. Who is right? B. On the test?
Is it B though?
It is C.
Nope.
They're both right. And the 10 is acting up here for a reason. Right? Okay. All right. All right. So where are we at? Was that the last one? It was, right?
Yeah.
Or no, that was the first one. Sure, I don't even remember. We haven't done B yet, have we?
No.
Okay, this is the same question. Okay, this question also, you might see,
A.
right? Hey, we did that one. This one you might see later too.
Is it, C?
Is it C?
Yeah.
No. Okay. We did this one. Okay. Diodes are usually replaced how?
The C.
I'm sorry?
C.
C? Yep. Replaceable rectifier bridge component. What is being performed in this illustration? The engine is running. The meter is set where? It's hard to see, right?
Yeah.
This is actually AC volts, okay? What's being done here?
Is it B?
Is it B?
Yeah.
It is not
A.
B.
A.
Because the meter is set to AC volts, you are doing an AC voltage ripple test. Which of the following we did? Okay, what's being performed in this illustration? Meter is now set to DC volts, it looks like. Let me look. Because these meters that like this are actually all the same. So that is, that would be the DC volt setting, wouldn't it?
Yeah, the second one.
So it would be, that's AC, that would be the DC one, right? Okay, meters on DC volts, okay?
last.
So what are they checking there?
Positive.
For the output, voltage drop test.
Alternator output voltage drop test, yeah, positive, output wire, DC volts. Okay. One more question and we're all done.
Oh, we did it.
We did this one, didn't we? Yeah.
That one.
Alternator belt, loose.
Is that it?
We can do a few, practice test questions, different than ones we did. We did 25 yesterday, right?
Yeah.
Okay, so let's go, see, oops. A6, let's look for a, different one, let's see. No, let's not do that one right now. How about this one? We're gonna view answers as we go so we know if we got it right. Okay. I think there's only 10 of these questions. Nope, there's actually 20 of them, okay. We'll do these 20 and then we'll, be done. We'll do the testing and review and all that stuff tomorrow, and we'll go outside and do some actual on-car stuff, okay? Digital multimeter function set for a voltage drop. Meter lead should be connected in which of the following ways?
Did
Okay, well, let's read the question. You're using a digital multimeter to check for voltage drop. It doesn't say if you're checking for it on the ground side or the positive side, right? Since it doesn't specify, how do you hook the meter leads up? It wouldn't be A, right? Because it says positive side. It doesn't specify. Again, I don't know the answer to this. I'm guessing that that's what they're trying to say. Do you put the leads across the component or the circuit? Yes, you do. Just so you know. Voltage is always checked in parallel across the circuit or the device. Again, we'll do some of that on-car testing tomorrow. And we'll check the belt tension to see how you guys did on her car.
Okay.
Okay, which of the following is correct regarding a series circuit? Oh, anybody remember that? Stay with us here, brother. Which of the following is correct regarding a series circuit?
The higher the circuit, the higher the voltage.
B.
What did you say?
B.
D?
D, highest resistance has the highest voltage drop. How do you like that answer? That is a great answer, because it's true. Highest resistance has the highest voltage drop. Hopefully you didn't guess at that.
I thought of it.
Well, I'm hoping you didn't guess, because that's good. That means you knew that or remembered it. That's way better than guessing. Okay. You have a meter now hooked up to measure DC voltage, connected in parallel to the load device. Which of the following defines the reading. We saw this on a previous question. Remember when it said the leads go across this device or circuit, the load or circuit? What was being done?
Rose is the same thing as the other one?
Mm-hmm.
Both
Yep.
leads drop.
Yep. Remember? Connected in parallel to the loaded device? That was similar to question number 1, remember? Okay, which of the following tools is used to check continuity of wires that carry digital signals?
Digital.
Digital.
I'm going with B.
You know what, B?
Yeah.
All right.
Wait.
Remember digital and analog are opposites, so you can't check digital with an analog meter, so I'll just tell you that that is not possible.
Nuh-uh.
There's no such thing as a megameter.
Yeah.
That's why that probably looks funny.
So is D.
I don't know, let's see. How about logic probe? Okay. Another meter question. You got a fully charged 12-volt battery. How much voltage on the open circuit voltage test should it read?
D.
12.6 is a good answer. 2.1 per cell times 6 cells. We've been through that on our battery lesson. State of charge, specific gravity, 1.225 at 80 degrees Fahrenheit indicates it is approximately 75% charged. Is that right? Remember 1.265 was fully charged? So that's probably about right, right? Your specific gravity number goes down as the battery discharges. Technician B says you can use a hydrometer to check the battery's state of charge on a maintenance-free battery. What is a maintenance-free battery? It's a battery that is pretty much every one of them out there now. It means you can't take the caps off of it and check it with the hydrometer, check specific gravity, thing like that, right? So yeah, you can't do that. Okay, just A. When performing a load test on a battery, a technician finds that what the heck happened to? He spends more time there than he does in the classroom. I don't get that. Performing a load test on a battery, technician finds the battery voltage drops below specs. What's the most likely action to perform?
Replace it.
If it drops below specs during a load test, yep, replace the battery. It's no good. This is what you guys normally use to test batteries. Conductance or continuity tester. Tech A says D's going to load test a battery. Tech B says you need to make sure the ignition and all accessories are off.
C.
What's that?
C.
C?
Yeah.
How about B? They cannot load
Most
test
is loaded.
a battery, okay? These continuity and conductance testers can't load test a battery, okay? Just B. You've got an alternator that's not working, 0 output. Tech A says the field circuit may have an open. Tech B says fusible link may be open from the battery to the alternator. Both of them caused that, wouldn't it?
Yeah.
Okay. This question has the word least in it. An alternator has low output, being full fielded to determine the cause. Full fielded means you're forcing the alternator to put its maximum output possible. Which of the following is least likely result? Exactly. If you're forcing the alternator to do all it can, these are things that could happen. This is not. Okay. Loose belt. Tech A says a loose belt can cause overcharging. Not a chance. If the belt's loose, it's going to undercharge, right? Because it's not spinning fast enough. Tech B says undersized wiring between the alternator battery could cause overcharging. Meaning the wire between the battery and the alternator is too small. Is that going to cause overcharging? Hell no. It's going to cause that wire to probably burn up and melt, right? So they both should be wrong, right? What the heck's going on here? Slip. Technician A is wrong because the slipping belt will cause undercharging. Technician A says a loose drive belt could cause overcharging. They don't even know how they worded the question.
Yes.
A loose belt can cause overcharging? No. Undersized wiring could cause undercharging? Absolutely. So you know what? They're wrong. And we're right. Okay, belt tensioner. Tech A says when you install a new belt, the three lines should lines on the tensioner should line up very closely to the arrow on the base. This guy says the belt should be replaced when the single line mark lines up with the arrow on the base. Which one is it? Both of them? Both of them, all right. We haven't got to lighting circuits yet, but this deals with lighting circuits. HID headlights are generally brighter and have a blue tint. Is that right? HID headlights, are they normally brighter and have a blue tint?
I guess.
HID headlights?
Those are like
Those are, yeah.
the regular ones, right?
No, those are the high intensity discharge ones. They are normally brighter and have a blue tint, so that is actually right. Defective turn signal bulb on one side can cause a turn signal on that side not to blink.
Wrong.
Just A?
Yeah. Wait. So
Defective turn signal bulb on one side can cause a turn signal on that side.
So if one go out, they both go out?
Wait a minute, let's read this carefully. Defective turn signal bulb on one side can cause the turn signal on that side. Okay, on that side. Okay, yeah, if it said opposite side, that would be wrong, but yeah. So what they're saying is if the bulb is bad, will it not blink? Yeah, of course. Okay, so that is right. I almost misread that myself. Okay, least likely to be cause of a dim headlight. I really like it if you could stay in the class more often.
I'm sorry, I'm focused on because it's bugging me for the last few days.
All right. What's the least likely cause of a dim headlight?
Is it B?
It's least likely.
Oh, low alternator output because it's also.
All right. Okay. HID headlight again. On a floor level with an unloaded vehicle, what you said, you should aim the headlights on a level floor with an unloaded vehicle. Okay, says aiming headlights, you must follow the state inspection specifications.
Both?
I'm guessing both, yeah. Again, we haven't done anything with lighting circuits. That's coming up next week. You guys ever seen those headlight aiming screens in the dealers? They actually have a special screen that they set up and start aiming headlights on certain cars. Okay. That should
Is
be.
that when they move around?
I'm not even sure which one of these is it. Oh, mechanical aimers. No, it's these. I'm sorry. What?
Is it when they move around in the headlights? Like when they go up and down, like the headlights?
That's a different type of headlight. These are just this aiming screen. They set the vehicle on there, turn the headlights on, and you can adjust them to where they're supposed to be. Because you don't want them too low, you don't want them too high, because otherwise they're blinding other drivers. If they're too low, you can't see far enough down the road. So they use headlight aiming screens on some of these cars.
Are we on 17 or 18?
17. Which of the following describes most common type of electrical wiring used in instrument lighting?
Is it B? Copper stranded type?
Stranded copper is pretty much all they use in cars.
C.
you guys should know this one.
Rosin core.
We've done this before. Dash indicator warning light does not light when the key is on or in the start position. Dash indicator warning light. It doesn't say which one, does it?
No.
A dash indicator warning light does not light when the key is on or start position.
Battery
Battery.
level.
That doesn't make any sense, but this is what I would guess. No? No?
Well,
Okay, you say so.
If a fuel gauge reads full, which of the following is most likely cause? Huh?
The fuel gauge.
Fuel gauge reads full and the tank's not actually full. What they're saying is the gauge reads full, but it's not. So there's a problem in the circuit somewhere. What's your guess here?
It could either be B or A.
broken gauge.
I'm assuming they're gonna
Is the
say
wiring
A.
usually?
What's the float? The stick?
I'm thinking it's
Yeah,
a float.
gas tanks have a float in them.
Yeah,
right.
I'm thinking it's a float.
And it floats with the fuel level, and that is a variable resistor, and that sends a voltage signal to the gauge, so you know how much gas is in your car. It's got a little float arm on it, right?
So B.
I
It's
think
stuck
it's
up.
float, but knowing how they're,
Stuck in the up position,
it's probably broken gauge then.
broken gauge, he says. No, grounded wire to the sending unit. Who said wire, you?
Wire, 2, 7.
Yep. Okay.